Welcome, pre-calculus students, to another lesson in our unit on the unit circle and trig. In today's lesson, we will continue graphing trigonometric functions, but this time we'll look at graphing trigonometric functions with some added transformations sprinkled in. Okay, so we've looked at graphing trigonometric functions with amplitude and period. Now let's revisit our transformations and see how that changes our graphs. So let's get to it. So let's quickly review some of our transformations, and more specifically, let's review translations. So shifting a graph up and down, left and right. Let's review that first. So here we have a couple of examples here. So number one, y equals the quantity x minus 1 squared plus 2. So all we're gonna do for this equation is just describe the transformations that are occurring in this equation. Well, if you recall, whenever we add or subtract a number, in our function equation, we are shifting the graph, we are shifting the function up, down, left, and right. Now, if you remember, whenever you add or subtract to x, so in this case, x minus 1, whenever you subtract or add to x, that is when you are shifting your function left and right. In this case, when you subtract 1, that would be a shift right 1. Okay, so that would be a shift right 1. If you remember, it's because you actually do the opposite. Even though you're subtracting 1, so you would think you're actually shifting the graph to the left, when you're adding and subtracting to x, you do the opposite. So you're actually shifting to the right 1. And then when you're adding to the equation, to the entire equation, so you're not just adding or subtracting to x, but you're adding or subtracting to the entire equation, such as this plus 2, that's when you're moving up and down. So in this case, you would just be moving up 2 units, all right? And now in number 2, we basically have the opposite. Number 2, we have x plus 2. So in this case, instead of moving to the right, you move to the left, because once again, it's the opposite. So you move left 2. And then we have minus 3 on the outside there. So we're subtracting 3 from the entire quantity as opposed to just to the x. This would give you a shift down 3. Okay? So that was just a quick review of our translations. So shifting a function or a graph left, right, up, and down. So let's apply this to trig graphs. So here we have basically what a trig equation would look like if you were to include its amplitude, its period, a shift left and right, and a shift down. Okay, we've already talked about that A is just the amplitude, so we covered that in a previous lesson, and we also covered that the period is equal to 2 pi over b. Okay, so the period is equal to 2 pi over b. Actually, just ignore that part. So the period is equal to 2 pi over b. So we talked about that. And we just discussed what C and D do to our graph. Sorry. So the C value, as you can see here, that C value is going to shift your graph left and right. Okay, it's going to shift your graph left and right. And then that D value that we just talked about, whenever you're adding or subtracting to the entire quantity, not just to x, that's going to be shifting your graph up and down. Okay? So the transformations are going to work exactly the same way they worked for when we did other function equations, all right? Whether it be exponential functions, logarithmic functions, square functions, cubic functions, they're going to work the exact same way. Now, one thing that you'll notice, and this is important when you're writing equations, this will come into play when you're writing equations, is that you'll see that the b value is outside a set of parentheses, okay? So you'll see that whenever you have a number being added or subtracted to x in a trig equation, whenever you have a number added or subtracted to x in a trig equation, you're going to have that inside of a parentheses. So you're going to have x minus 2 or x plus 3 inside of parentheses, and then the b value is going to be on the outside, as you can see. Okay, and you'll see that as well in the examples that we're going to be doing today. So just that's a small detail to remember going forward. You got to write that set of parentheses there. All right. So let's before we look at our first example, let's go over a couple of basically steps that we're going to follow. So the strategy that we're going to be covering in this lesson is very similar. It's exactly the same strategy that we once used when we graphed exponential functions with transformations, or even logarithmic functions with transformations. And the strategy is we find what you would call base points, and you'll see in a second what I mean there. We call base points using just the amplitude and period. So we completely ignore the other transformations. We focus on just the amplitude and period of the graph. We find those points first, and then we shift those points using transformations. So we literally take those points that we just found, and we move them up, down, left, and right appropriately based upon whatever the transformations are. And then obviously you connect the points to make the curve. Okay, so we've used this strategy before. This is not the first time we've used said strategy. So let's look at this first example. Graph the function y equals sine of the quantity x plus 2 pi minus 2. Okay? So first, let's identify the amplitude. Well, the amplitude, remember, is the a value. And the a value is whatever is in front of this equation, or being multiplied to this equation. Well, in this case, it looks like there is no a value, but there is. The a value is 1. Remember, just because it is not written there doesn't mean there isn't an a value, it just means the a value is 1. So that means our amplitude is also 1. All right? Now let's talk about the period. Well, remember, the period is determined by the b value. Well, the b value is whatever number is being multiplied to this x. Well, once again, it looks like there is no b value, but that is because the b value is 1. All right? That is because the b value is 1. Now remember, the period is 2 pi over the b value, which in this case, since it is 1, 2 pi divided by 1 is just 2 pi. So nothing has changed there. So let us do the graph just based upon that. So in other words, at this point, we're actually going to ignore this and this. We're going to ignore the transformations. We're just going to graph, or we're just going to find points based upon what the amplitude and period are. That's it. All right? So if you remember, our strategy for filling out a table is we basically pick our first point. The most convenient is always going to be 0. And then our last x value is going to be wherever the period ended. So in this case, 2 pi. And then the values in between, right? The values in between. So in between would be 1 pi. And then between 0 and pi would be pi over 2. And then between pi and 2 pi would be 3 pi over 2. Okay? Or if you use that alternate strategy, remember I also talked about that alternate strategy the other day, you would take your period, and divide it by 4, okay? So it'd be 2 pi over 4, which would simplify to 1 pi over 2, which is exactly what we had here. And then to find the next x value, we would take what we just got and multiply it by 2, which would give us 2 pi over 2, which would just reduce to 1 pi because the 2's would cancel out. And then to find that fourth x value, we would take that second x value, pi over 2, and multiply it by 3 this time, which is why it would turn to 3 pi over 2. So that was that alternate strategy that I talked about the other day. So regardless of which strategy you use to find the x values, those would be your x values in the end. All right. Okay. So now let's talk about the y values. So remember, the y values, we just plug them into the equation. So the first one is 0. So since everything here is just 1, right? Everything here is just 1, so we just end up with sine of 0. Sine of 0, look it up on our unit circle, is going to be 0, because that is what the y value is. Sine of pi over 2, look it up on the unit circle, would be 1. Sine of pi would be 0. Sine of 3 pi over 2 would be negative 1. And then sine of 2 pi would be 0. Okay, so we have our points. And let's actually quickly plot those. So I'm going to plot them here. So let's, let me think, give me a second here. How do I want to do this? Actually, you know what? I'll just leave them like that. for now. I'll just leave them like that. Okay, so we figured out the base points, quote unquote, the base points. So now let's figure out what the points would be if we factored in the transformations. So to do this, I'm going to have to erase this because I need this space here. So now let's talk about the transformations. Well, the transformations, if I now erase the fact that I blacked out the transformations, the transformations would be these two, right? This would be your C value, and this would be your D value, okay? Well, remember, the number that's being added or subtracted to x, the C value, that is telling you how much to move left and right. So in this case, because it's plus 2 pi, that means our transformation would be left 2 pi, okay, it would be left 2 pi, and then that D value, the number being added or subtracted to the entire quantity, would be moving up and down. So since it is minus 2, that's going to shift our function or our graph down 2. All right. So now at this point, that's what we're going to do to each of our points. So to the x values, we're going to shift them left 2 pi, and to our y values, we're going to shift them down 2. Okay? So I'm going to construct another table here. I got that. Bam, 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 bam. All right. So x, y. So what are our new x values? Well, remember, we're taking each of the x values and shifting them left. Well, if you shift x values to the left, right? If you shift x values to the left, you're going to be subtracting from them. So we're going to take each of our x values and we're going to subtract 2 pi from them. Take each of our x values, subtract 2 pi from them. So the new x values become negative 2 pi, because 0 minus 2 pi is just negative 2 pi. 0 is going to be at the end there, because 2 pi minus 2 pi is just 0. We're going to end up with negative 1 pi, because just think, if you have 1 pi and you minus 2 pi, you end up with negative 1 pi. Negative pi over 2, and then negative 3 pi over 2. So those are going to be your new x values, your 5 new x values based upon shifting them left 2 pi. And then our new y values, since our transformation was down 2, right? Our transformation was down 2. That means all our y values are also going to be subtracted by 2, right? Because if you're shifting something down, the y values are going to become 2 less. So in this case, let's see. These should be pretty easy. So 0 becomes negative 2. 1 becomes negative 1. 0 becomes... Wait. No, I did it right. 0 becomes negative 2. Negative 1 becomes negative 3. And then 0 becomes negative 2. And then, you can easily verify these in a calculator just to make sure you're doing them correctly. 0 minus 2, 1 minus 2, 0 minus 2, so on and so forth. So these are the points that we're actually going to be plotting. So let's do that. So, let's see. It doesn't really matter. I'm going to make the end negative 2 pi. I'm going to make the end negative 2 pi so that then the middle would be negative pi, and then 0 is just 0. So at negative 2 pi, I have negative 2. We'll make that negative 2, that positive 2. At negative 3 pi over 2, which would be in the middle between... Actually, let me do negative 2 pi is negative 2, negative pi is negative 2, and then 0 is negative 2. Okay, for a second there, I thought I did something wrong. Okay. And then let's see. In between negative 2 pi and negative pi would be negative 1, which would be right here. And then in between negative pi and 0 would be negative 3, which would be here. So we have our curve. We have our curve. And then once again, if we wanted to continue, we could just keep on going, right? Because since this is one period, that means the points just keep on repeating. So it looks like our next point after this would be negative 1. And then it's going to go back down to negative 2, down to negative 3, and then back up to negative 2. All right, so there, if we wanted to graph one more period there, right? That's one period, and that's one period. All right, they just consist of the exact same points. Negative 2, negative 2, negative 1, negative 2, negative 3, negative 2, negative 1, negative 2, negative 3, negative 2. So it just keeps on repeating up and down, right? So that's how you would do it. That's how you do it. So let's look at one more example. So example 2. So y is equal to 3 cosine of the quantity 3 times the quantity x minus pi over 3 plus 2. So this one's a little bit more complicated. So once again, let's do the amplitude. Well, once again, we know the amplitude is that a value being multiplied in front. So it's 3. So that's our amplitude. Now let's do the period. Well, in order for us to know what the period is, we have to figure out what the b value is. Well, the b value is 3. Okay, the b value is 3, which means the period, because the period is 2 pi divided by b, is going to be 2 pi over 3. Okay, so our period is 2 pi. And once again, now we're going to do the base points without the transformations, right? Now we're going to do the base points. So just ignore this. Pretend that's not even there. Okay, pretend, oh, that's not even there. Okay, so we're just going to do points based upon this equation at this point. All right, so let's do that. So we have our x and our y. Okay, so remember our first point is 0, because that's the most convenient one. And then our last x value is going to be where the period ends. Okay, so let's see. So halfway between those is going to be pi over 3. Then halfway between those is going to be pi over 6. And then halfway between those is going to be so pi over 2, actually. There you go. Okay, and then once again, if you use that alternate strategy that we covered in class of finding the x values in between, you would have ended up with the period divided by 4, which, remember, when you divide something by 4, that's the same thing as multiplying by 1/4. So that gives us, what does that give us? That gives us 2 pi over 12, which reduces to 1 pi over 6, right? And then we would take that, pi over 6, and multiply it by 2 to find the next y value. So 2 pi over 6, same thing as 1 pi over 3, because the 2 and the 6 reduce to 1 over 3. And then to find that next x value, we would take that that pi over 6 again, but this time multiply it by 3, giving us 3 pi over 6, which gives us that 1 over 2, right? Because 3 over 6 reduces to 1 over 2. All right, so now let's plug them in. So let's see. So if x is equal to 0, okay, if x is equal to 0, we end up with 3 cosine of 0, right? Because 3 times 0 is just 0. So cosine of 0, if we look it up on the unit circle, is 1. So here we have 3 times 1. So our first y value is 3, because don't forget there is a 3 in front of our equation. All right, and then the next one, pi over 6. Well, let's see. We have 3 cosine. So pi over 6 times 3, right? Pi over 6 times 3 would give us 3 pi over 6. And 3 pi over 6 reduces to pi over 2. Okay, so pi over 2 on the unit circle, so that's 0. 3 times 0 is equal to 0. And then we can keep on going. So we have 3 cosine pi over 3 times 3, because whatever x value you plug in, you have to multiply by 3 in this equation. So pi over 3 times 3, so that's 3 pi over 3. 3's cancel out. You're just left with pi. We look it up on the unit circle, that's -1. So it's -3 in this case. And then we keep on going. So pi over 2, let's see, what would that give us? So that would give us 3 pi over 2. On the unit circle, that's 0. Well, that gives us 0. And then finally 2 pi over 3. So that gives us 6 pi over 3. And that's just the same thing as 2 pi. So that gives us 3 times 1, so that gives us 3. So there are our y values. 3, 0, negative 3, 0, 3. Those are our y values. Tried to fit all the work inside that little table. So remember, that is our base points, quote unquote. But now, let's find the actual points by taking into account what the transformations are. So now let's actually erase all this, because now we're actually going to take into account what the transformations are. Oh, did I skip? I did skip a color. So this is our c value, so minus pi over 3. So since it's minus, so remember it's subtracting from x, that means it's going to move to the right pi over 3. So right pi over 3. And then we also have this plus 2. That's our d value. And since that's being added to the entire equation, not just to x, that's going to move up and down. So that's just going to move up 2. Okay? So to each of our x values, we're going to add pi over 3. To each of our x values, we're going to add pi over 3. Okay? Because since it's moving to the right, that means the x is going in the positive direction. Okay? So let's construct a new table here. There you go. There you go. Okay. Let me use a different color here. Yeah, there we go. All right, so to each of our x values, we're going to add pi over 3. So 0, well, if you add pi over 3 to 0, it just becomes pi over 3. If you add pi over 3 to 2 pi over 3, it becomes 3 pi over 3, which is just the same thing as pi. Right? So we're going to add pi over 6 to pi over 3, so that's going to become actually, oh, I got to think about it, because it's the same thing. So that's going to become 3 pi over 6, so that's pi over 2. Pi over 3 is going to become 2 pi over 3. And then pi over 2 is going to become 5 pi over 6. Okay? And then once again, you could, verify each of those in a calculator. So pi over 6 plus pi over 3 is just pi over 2, or 3 pi over 6 if you reduce it, and so on and so forth. All right? So now let's do the y values. So each of the y values we're going to add 2. So each of the y values we're going to add 2 since the transformation was up 2. So 3 becomes 5, 0 becomes 2, negative 3 becomes negative 1, 0 becomes 2, and 3 becomes 5. All right, cool. So let's see. So at pi over 3, okay, now we have to decide how we're going to label our points here. Thinking what's the best way. So had we done it that way, that would have been that. So I think we should just be able to do that. So it's going to start at pi over 3. Okay. So I'm going to make, or I think the easiest would be to make this pi over 3. So that means every second point would be an additional pi over 3. So that's going to be pi over 3, that's going to be 2 pi over 3, and then this is going to be 3 pi over 3, which is just 1 pi. Okay? Yeah, that's probably the easiest way to go. All right, let's see. So we have points, and then, we go as high up as 5. Wait a second. Whoops. Oh, well, that's small issue, but that means I'm gonna label this by 2's. So 2, 4, 6, and then this is negative 2. So the first one is pi over 3, 5, which means there's going to be, right, between 4 and 6, so 5. At 2 pi over 3, we have negative 1. Uh-oh. Erase that, put that over here. so it's not in the way. -1. And then at pi, we have 5 again. And then in between, let's see, so in between we have 2 and then 2. So it looks like our curve is going to look something like this. Okay, it's going to look something like that, all right? And then if we wanted to, we could continue on, right? So the curve has to keep going up and down, so that means the next one would be here, and then it would go down here. Let's see. So the next one would be here, and then there, and then the next dash here, and then the next one here, and then you can just keep on going with this. All right, if you wanted to. You don't have to draw as many periods as I did, but just to show, just to show that you can. You just keep on drawing these. There we go. Okay. So we drew basically this. That's the part of the curve that we drew, and then everything else is just additional periods that I drew, just with additional points, right? There's another period. There's another period, and then you can keep on going, right? So it looks like the pattern is 5, 2, -1, 2, 5, and then just keeps on going. So 5, 2, -1. So 5, 2, -1, 5, 2, -1, and then back up 2, 5, and then so on and so forth. Okay, so remember, there's a pattern here. It just keeps on repeating all the points. All right. And then example 3, I want you to try this one out. Try this one out on your own. So remember, base points first. So base points completely ignores the transformations. It just focuses on the amplitude and period part of the graph. Okay? So remember, you're doing these points first, and then for your quote-unquote second table, you would take into account the fact that there are transformations for this graph. Okay, so it can be a little bit tricky, I will be honest. Well, at least with finding just the x values. The y values are typically easy to change, right? 3 to 5, 0 to 2, -3 to -1. Those didn't seem too bad. But yeah, the x values going from one x value to another can be a little bit hard. So, feel free to use a calculator. Feel free to use Desmos if you want to figure out, for example, if you're trying to add pi over 3 to pi over 6 to get to pi over 2. So feel free to do that if it helps. But otherwise, the rest shouldn't be too bad, hopefully. Hopefully not. And like I said, remember, Desmos is always a useful tool to help you check your answers to make sure you actually have the correct points. Otherwise, that is it for today's lesson. Let me know, as usual, if any questions do pop up or if any confusions do pop up. Otherwise, I hope you guys enjoy the rest of your days.